All right, cool. So we started with the summary. Ne? This is the summary, statistics summary. Ne? Okay, we've got the mean, which is given by x. I don't know what they call this thing on top. X bar. Okay, yeah, x bar. And then it's equals to the sum of all the data given divided by the number of terms in that data. Ne? And then the median is the middlemost term. We need to reorganize or rearrange the data from the lowest to the highest. And then the position of the median is given by Q2, number of terms plus 1 divided by 2. Yeah, n is the number of terms or number of data. Ne? Number of data, what you have there. Ne? Okay, then we've got the mode. The mode is given by the most common term. Ne? Means the one that is repeating itself the most. Ne? Okay, statistics for grade 10. Yeah, there's some of the things, but grade 11 they add a little bit of the things, and then grade 12 they add those standard deviations and what. You've got standard deviation now. You also do that, yeah. So it's basically the same. I don't know how much marks is got in grade 11, but yeah, these are free marks. Yeah? These are just free marks. Number 4, we have the 5 number summary. Yeah? Number summary. In grade 12, I wrote 5 summary numbers. I said, no, it's not like that. It's 5. It's 5 number summary. Ne? Okay, let's see, 4.1. What do you have? You've got the minimum. Yeah? Yes. Which is the lowest number, 4.2. You have Q1. Okay, we have Q1, which is equals to 1 over 4 n plus 1. Yeah? This gives us the position of Q1. Not Q1 itself, but the position. Okay, where it's sitting on the data. Ne? Right. So, what else is there? Q1 is the lower quartile. Ne? Therefore, you've got 4.3, which is Q2. This one is given by n plus 1 over 2. This is the what? This is the median. You agree? Yes. Q2 is the median. Yeah? That formula gives us the position of the median. And then 4.4, we have Q3, which is given by 3 over 4 n plus 1. Yeah? Yes. Q3 is what? Is the upper quartile. Yeah? It's the upper quartile. Upper quartile. Yeah? That's the position. It's given by that. Okay. Therefore, you've got number 5, which is max. This is the maximum number on the data. Ne? Maximum number on the data. Okay. All right. What else? That's it. Ne? 5 number summary. We are going to use it to do what? To draw a box and whisker. Ne? Box and whisker diagram. Ne? We're going to draw box and whisker diagram. This box and whisker diagram needs to be on a number line. Ne? You must have a line to draw it. Ne? You must have a line, and then it must be sitting somewhere there on that line. Okay. Then Q1, this is minimum, Q2, Q3, and therefore max. x. Okay, so sometimes you're going to be required to comment on the skewness and the what of the data. Okay, so let's unpack that right here, right now. No? A, if the box in whisker looks like this, what does this mean? Okay, if it looks like this, the way that I always think about it is that when it's like this, what does this mean? It means most of your data is this side. Then you have got very little data that side. Okay, so because it's on the left, it's negatively skewed. Negatively skewed. Yeah, do you guys do skewed on the left, skewed on the right, or you just say negatively skewed? Negatively skewed. Yeah, cool. Let's pick on the negative. Okay, and then you would have it looking like this. There, most of the data is on the right. Most of the data is sitting here on the right hand side. Therefore, it's positively skewed. Positively skewed. Right, and then once it's like that, you might have it looking like this. Right in the middle, this one is normally distributed, normal distribution, distribution, or the data is what? Symmetrical, Yes, the data is symmetrical. What you have on the left is equal to what you have on the right. Okay. Are we missing something? Symmetrical data, the other way of finding out, if it's like this, symmetrical data, you can find out by saying mean minus median. If the answer is equal to 0, therefore your data is normally distributed. Yes, that's another way of finding that out. Then your data is normally distributed. You might have they're going to ask us for a range, which is going to be max minus minimum. And then they're going to ask us for interquartile range, okay, which is Q3 minus Q1. Semi-IQR, which one is this one? Semi-interquartile range. Okay, Q divided by 2. All right, great. Now, I had forgotten about this one. Semi-interquartile range, yes, 100%. Yeah, so now let's come to the frequencies. I think this is what is left on our summary. Frequency. Frequency, we're going to be given classes. Classes, you've got classes here. Then you've got the frequency here. And then you're going to have cumulative frequency. Okay, cumulative frequency. Okay, let's say for an example, you've got class 1, 2, 3, 4, 5. Just for an example, okay? And then let's say this class is started with 0, x, 10. I'm just doing this from the top of my head. Might not necessarily be true. 20, then 20, x, 80, 30 x 40 greater or equal to 50. Ne? Let's say here you've got 5, 4, 20, 35, 15. Okay, that's our frequency. Ne? They might ask us to draw what? Okay, no, before we can draw, ne? They might ask us for cumulative frequency. Ne? So now, cumulative frequency. Ne? In grade 10, they forget how to calculate the cumulative frequency. So I said, the way I used to remember it is, you say it's a zigzag calculation, ne? To get the frequency. The first one, 5, and then you add 5 to this, 9. Ne? Then you add 9 to this, 29. Then you add 29 to this, 64. Then you add 64 to this, 79. Ne? Therefore, the last number here, very critical, this 79 should be equal to the total number of frequency, ne? Which is the total number of your data. Is right. Yeah. So this is how you would check if you are correct. Ne? So yeah, I put the lines there, ne? But it's just to show that it's a zigzag calculation. Ne? Yes, you don't need to. There's no. If it's like this, you won't forget it. Ne? That's how you would get the cumulative frequency. Therefore, you're going to use the cumulative frequency to draw. When you draw the ogive, this is what you need to capella of. Ne? You're going to use these numbers again. You're going to use your cumulative frequency to draw the ogive. So ogive would be, fine, ne? Okay, number 10, ogive or ogive. Ne? When you draw the ogive, you draw the ogive with the classes. Ne? But this is where you start. Ne? You start here. Ne? This should be your first value on the x. This is x-axis. This is y. Ne? So you must start with the 0. After that, therefore, you can use these numbers. The ones on the right, on the classes, these ones. So when you draw the ogive, your ogive will look like this. It's good, but it must start at 0. Then the next number will be 10, 20, 30, 40. Whatever the number it is, ne, must always start with this number that is here. Even if it's 5. If it's 5, you start at 5. Okay. Please don't forget, ne? Because some they will just start here at 10 and draw everything. Then what about this value here? Because this one is going with 5. Ne? Then you draw the ogive, it's going to look something like that. Ne? Yes, then they might ask you using the graph, where is the middle term, what? We're gonna do those ones then. Using the ogive or using the classes. Ne? What is the middlemost classes? Ne? Wait, what is the mode? The mode is the one that is carrying a lot of data. It's where most of the numbers is the model class. Ne? Okay, number 11, standard deviation. Standard deviation. Ne? Standard deviation. The things that we need to know here, standard deviation. We need to know the formulae. Standard deviation is it's given by this. Even on your calculators like this, ne? Standard deviation, the sum of the data given minus x all over n. Okay. And then the one that is like this, it's the variance. Okay. They might ask you for the variance. Okay? Might ask you for the variance. If they ask us for variance, we know variance is just going to be standard deviation squared. Standard deviation, we're going to use a calculator, but we are going to explain what it means when we say 1 standard deviation away from the mean, 2 standard deviation away from the mean. We're going to explain that. Okay, please add this one. Please add this. We said when mean minus median is equals to 0, the data is what? Normally distributed. Okay? Normally distributed. Okay, let's see. So if that's the case, what about when mean minus median is greater than 0? Then this simply means positively skewed. Yes. And then when the mean minus median is less than 0, this is negatively skewed. Okay, yeah. You can also see it on the box and whisker, but this is another way of checking it's another tool. You can just double check your answer. Yes.